Hello everyone, we're Team Parzimes. Myself, Sri Harini, and my teammate Sri Sarvesh have worked on Team 1, Automated AI-based Financial Transaction Categorization. Financial apps depend heavily on turning messy transaction text into clean categories for budgeting and analytics. Most companies rely on costly third-party APIs, which create scaling costs and latency issues. There's a clear need for a fast, private, in-house systems developers can fully control. Transact IQ, which is our end-to-end AI-powered transaction categorization engine that combines a hybrid ML model, real-time streaming, privacy layers, interoperability, and a complete developer dashboard, all deployed and ready for practical use. So we trained on a 4.5 million record data set, and we also created a 75,000 synthetic data set containing noise, typos, rare merchants, adversarial texts, and anomalies to test stress test robustness. We experimented with logistic regression, XGBoost, and a linear SVM, and also tested BERT style LLM encoders. And the LLM based classifiers had high accuracy but came with major drawbacks, which is slow training, expensive fine tuning, and high inference cost at scale. Shallow ML models trained fast but struggle with unseen merchants and semantic drift. So our final design uses XGBoost plus sentence embeddings and prototype classification. This gives us the raw speed and stability of classical ML, the semantic understanding of transformer embeddings, and interpretability of prototype centroids. Most importantly, the prototype layer means you can add completely new categories without retraining the model. You only update the config and recompute prototypes, and the system starts recognizing them immediately. So this balances of accuracy, flexibility, and zero restraining extensibility, which is zero retraining extensibility is what makes the architecture powerful in a real world fintech settings. At a high level, the system has three layers: a privacy layer that anonymizes user details, hybrid categorization model, and a full stack app with fast API backend, a React dashboard, a live streaming, and a feedback loop. Nothing is exposed outside. We keep everything fully self hosted. Moving on with the demo, we'll be explaining.
Yeah. So the dashboard gives an at-glance view of the model performance. It shows the hybrid macro F1 accuracy, latency throughput, category distribution, and the recent predictions. It updates in real time whenever new transactions are processed. So we basically worked with 4.5 million dataset points, and we achieved an F1 score of 0.99 of average F1 score per category. And we have also implemented a live stream real-time streaming environment to showcase our model. So we support a structured taxonomy of spending categories like food, dining, transportation, etc. So these categories are defined in a config file. So each category is described in short sentences, and there are lots of keywords that are embedded in these categories. A user can add any new category, and also they can make the model predict the new categories without retraining them. So, for example, you can take a small demo. So here, you can type a transaction like Starbucks Chennai TN with an amount and a date, and the system anonymizes personal details, predicts category, and confidence and risk tier intensity. So here our model predicts that this transaction is categorized as financial services, and it's 100% confident. And it also says what are its neighbors, which are food and dining, shopping and retail, and utilities. So here our model anonymizes before it is encoded, so that no personal details are being given to the model, and the privacy and safety of the users is ensured. So here, uh, the evaluation tab shows the FN scores and confusion matrix. So basically, we have two stages. So first is an embedding stage where a sentence transformer embeds the meaning of the transactions and then stores as a matrix. Then we give this to an XGBoost model, and this XGBoost model is trained on this embeddings. And then if a new category is added, we also have a classifier, new classifier head called prototype classifier head. So if a new category is added, this prototype classifier, which is based on KNNs, can categorize these transactions. So we achieved a total hybrid FN score of 0.99, and this shows the classification matrix. So we have also given a Gemini powered analysis of the classification matrix to show that to explain how our classification works. So and then to be to go to the benchmarks. So here we do a thorough benchmark. We analyze the performances and the performance metrics of our model. We see a real time throughput and latency of every transaction, and we see that we have achieved a very fast and a reliable transaction score. We also generate a bias and fairness report, which shows the bias between merchant, country, and amount bracket. We do this with a test set so that we can get an average idea of what the bias is, and also we can say how we can mitigate the biases, and this gives detailed insights on how these biases are distributed. So we can go to the live stream demo. So in live stream demo, what we see is, so as you can see, the bias report is done. So in the bias report, we see that the bias is very low among 5 different regions, and we also see the bias categorized on amount by accuracy by amount bucket. So if you go to the live stream demo, in the live stream demo, we live stream the transactions. So here, each transaction is categorized in real time, and Gemini here and the Gemini model also tells what these transactions are, why this transaction has been categorized on that category, and it also tells about the risk of this transaction. It tells if this transaction is risky or non-risky, and it scores this in a risk parameter and says if it is a medium risk transaction, low risk transaction, or a high risk transaction. So this will give us an insight on suspicious transactions, and we can easily flag them. So this during streaming, dashboard updates in real time so that all the live throughput and live average latency can be clearly seen. And moving on, we have implemented a human in the loop feedback section where each transaction is which are taken into the human in the loop feedback menu. So if you feel that the transaction is not categorized correctly, or if you feel that you need to supervise this transaction, let's assume you take this transaction. This has been categorized on financial services, and if you feel that this transaction comes under government and legal category, you can just select this and submit the feedback. So here the model learns from this feedback loop. So the model reviews these predictions in the feedback tab. Corrections are sent to the model, and these embeddings are updated online, and the feedback JSON is stored for offline retraining and audit purposes. So this concludes our demo, and we have implemented all the necessary functionalities, and we think that this will lead to a real-time financial transaction categorization that accommodates all the real-time difficulties and the scenarios.
So moving on to the business impact and the applications, Transact IQ significantly cuts costs by eliminating per API fees, improves privacy since data never leaves the system, and gives complete flexibility to adapt the model to new merchants or regions. It's ideal for neobanks, budgeting tools, and credit card dashboards and fintech analytics systems. In short, Transit IQ transfers messy financial text into structured intelligence, fast, private, accurate, and production ready. Thank you. We'd be happy to walk you through the live demo.